Okay, so the next topic is from unit number 3. Now this is converting the regular expression to finite automata. So we look at the first method now. So there are three different rules that this method utilizes. So this is rule number 1. So if I have A into B, I will be connecting A and B using this epsilon transition. Here is the second rule. So A plus B is A or B. So this is A, this is B. Connecting epsilon transitions prior and after leading to the final state. This is the second rule. Third rule is to represent A star, that is repetition of A 0 or more number of times. So I'll write A here. There will be a back transition of epsilon to the previous state. From the state here, there will be a forward transition and another two epsilon transitions here. So this is a rule. So these three diagrams you need to remember so that you can construct the finite automata corresponding to any given regular expression. So now for example, this is A star or B star. So I'll represent A star here. Next is B star is represented here. Now how do I connect A star and B star? Using the plus rule. So plus rule says add epsilon both sides here and both sides here to get the final state. Okay, so continuing with the first method, this method is also called as converting regular expression to finite automata, and the automata which it generates is NFA with epsilon because it contains epsilon transitions. Now I can at once draw the diagram or I can break up this string into different parts. So I can say, for example, I call this as X, I call this part as Y, and I call this part, now this and this is same, so this remains X as it is. Okay, so I can represent X first and then I can represent Y, and then I'll say the final answer that I'll have is something like this. So wherein I have X and followed by, so we are multiplying this, so there should be an epsilon connection. Next I have Y, then epsilon connection, and followed by X. So this is X, Y, X. So X, Y, X in multiplication connected with epsilon transitions, and I'll go to the final state here. Now you can name these states as you wish to. You can keep the names as you wish. Now for X we can start representing X here. Now what is X? This is 0 or 1 the whole star. So I'll represent 0. Next I'll represent 1. Now this needs to be connected using OR. So 0 and 1 we have to connect it using the OR operator. So connecting with OR is prior and option, we prior to this and after this we have epsilon. So this is 0 or 1 represented, but now we have to make this as star representation. So I'll have to bring 1 and 1, two more transitions, connect them, two more states, connect them with epsilon. And for connecting the other two arrows, so one edge was going backward with epsilon and the other was coming forward with epsilon. Now we will not represent any initial state representation here because we have already done it here, and here X is not my initial state, so I cannot give the initial state mark here. Next is Y. So this is 0, 0 plus 1, 1. So I'll have to represent 0, 0 first. So to represent 0, 0, the connection would be with epsilon. And next is 1, 1. So this is connecting 1, 1 with epsilon. And now place both of these with the plus representation. and the transitions would be epsilon transitions. So all these circles are our states which we can give names, or you can keep it as it is.